Welcome to this session. I am Dr. Sreekanth, Professor, Department of Data Science in Institute of Aeronautical Engineering College. And today, this session, we are going to discuss the extremal elements in Posets and Lattice. So here, what is extremal elements in Posets? An element A is called a maximal element, of A if there exists no element X which is not equal to A in A such that A related to X. In other words, A belongs to A is a minimal element of capital A, the set A, if whenever there is an X belongs to A such that A related to X, then we can say X is equals to A. This means that A is a minimal element of A in the Hasse diagram of R. No edge starts at A. Next, another one, an element A is called an element A belongs to A is called a minimal element. See, last time, if an element A belongs to A is called a maximum element of A if there exists no element X which is not equals to A in A such that A is related to X. That means I am saying that in any partially ordered set, let us I am going to consider. So I am just taking 2, 4, 8, 16 is one set and the relation is divisibility if I am going to consider. Then the Hasse diagram for this, we are going to take it as, let us say 2 is related to all the elements, 2 divides 4, 2 divides 8 and 8 divides 16. So here an element is, suppose A, that is 16 belongs to A. This is A I am taking. A is equals to the set 2, 4, 8, 16 is the set. An element 16 is said to be maximal element if there is no element in the set where 16 is related. There is no other element. 16 is related to that element. All the elements are related to 16. So then in this way we can call it as a maximal element. And an element A belongs to A is called a minimal element if there is no element X in A such that X related to A. That means here 16 is the maximal element and 2 is the minimal element, but because there is no X, there is no value in the set A which is related to this 2. So this is known as a minimal element. So an element A is said to be maximal element. There is no other element in that set where A is related to that. An element A is called a minimal element, means that there is no X belongs to A such that X is related to A. So here in this diagram, in this partially ordered set, so A, the set A is 2, 4, 8, 16 and a divisibility relation will be there. Then its Hasse diagram is like this. So here 2 is the minimal element and the maximal element is 16. So next another one is an element A is said to be greatest and least elements. An element A is said to be is called to be greatest element if all elements, that means for every X belongs to A, which is related to A, then this is known as the greatest element. So here in the same example, so 2 is related to 2, 4, 8, 16. And similarly 4 is related to 4, 8, 16. And next 8 is related to 8, 16. Whereas 16 is related to 16. Now you observe all the elements are related to 16. Whatever the elements are there in the set which are related to 16. So we can say that 16 is the greatest element. So an element A is called a greatest element of a set A. For each and every element of the set, A is related to that particular element. And next, an element is said to be least element of a set A. So it is related to all other elements of the set. It is related to all other elements of the set. So here 2, if I am taking, 2 is related to 4, 2 is related to 8, 2 is related to 16, 2 is related to all other elements. So we can say that 2 is the least element. 2 is the least element. So these two, not for all Hasse diagrams. Some Hasse diagrams may exist, may not exist. Greatest elements. And the least elements also may exist, may not exist. Whereas the maximal and minimal values always are going to be exist. Always are going to be exist. Let us consider, I am taking another example. Let us say this is, so one is the set, I am taking A is equals to, the set A is 2, 3, 6, 12, 24, and I am just taking 2, 3, 6, 12, 24 and 36. Let us consider I am taking this. This is the set, and of course the relation is, divisibility. I am taking the relation. Then the Hasse diagram of this is, so here there is uncomparable elements are 2 and 3. There is no relation. 2 is not divides 3. And next 2 is related to 6, whereas 3 is also related to 6. So I am going to write in the higher level. And of course 6 is related to 12, and 24 and 36 both are uncomparable. There is no relation between them. So I am just placing those elements in that order, and I am going to connect all the things. So here 2 is related to 6, 3 is related to 6, whereas 6 is related to 12, and 12 is related to 24, 12 is related to 36. So observe this in this Hasse diagram, and here 2, 3 are the minimal elements, because 2 and 3 say are said to be minimal element. There is no other element which is related to these two. So I can say that 2 and 3 are minimal elements, whereas 24 and 36 are maximal elements, because it is not related to any other element in the set. So we can say that 24 and 36 are maximal elements, whereas the least element and greatest element does not exist. So here there is no element which is related to all the other elements of the set A. So here I am taking 2. 2 is not related to 3. Of course 2 is related to 6, 12, 24, 36, but there is no relation between 2 and 3. So similarly 3 is not related to 2. So there is no least element. And for this such diagrams, there is no least element and there is no greatest element. Only for this Hasse diagram, we can say that the minimum and the maximal elements are going to be exist. So here, while greatest element is going to be exist in any Hasse diagram, so that greatest element must be 1, and the least element also must be 1. In the same way, whenever the maximal elements need not be unique and a minimal element need not be unique. Some cases, whatever we discussed earlier, So 2 divides 4, 4 divides 8, and 8 divides 16. If I am going to consider here, the minimal element is 2, maximal element is 16, whereas 2 element 2 is itself is known as the least element, and the greatest element is 16. So here minimal is equals to least, and the maximal is equals to the greatest. So for some cases it may exist, and some cases it may not exist. So now let us consider the other one. An element A is called the upper bound of a subset B of A if X related to A for all X belongs to A. For all X belongs to A. So here, let us, I am just considering. So here, upper bounds. What are the upper bounds? So whenever if you are going to speak about upper bounds, we have to consider the subset of A, subset of the given set. So let us consider, if I am taking B as, let us consider 2, 3 is a subset. 2, 3 is a subset. So once if I am taking the subset B, then I have to consider what are the upper bounds. What are the upper bounds? Suppose if I am going to consider, let us say this is B, and B1 if I am taking, let us say I am going to take 2, 6, and if I am going to consider another one is, let us say B2 is another subset, B2 is another subset, which is, let us say 6, 12, 6 is 12. Like that we can get so many subsets of the given set A. So for each and every subset, there are some upper bounds and there are some lower bounds. So here the concept is the element, let us say 2 is called an upper bound of a subset. The set 2 is called an upper bound of a subset. 2 A belongs to A is called an upper bound of the subset if X is related, X belongs to B, 2 is related to this and 3 is related to this. So this condition is exist. 2 is related to 2, 3 is related to 2. So it is not possible. It is not possible because there is no relation between 3 to 2. So 2 is not an upper bound. 2 is not an upper bound. Next, go to the next case. Next element is 3. Next element is 3. Similarly, 2 is related to 3. There is no 3. Of course, 3 is related to 3. And 2 is, there is no relation. So 3 is not an upper bound. 3 is not an upper bound. Let us consider the next element, one is 6. So here 2 is related to 6 and 3 is related to 6. 2 is related to 6 and 3 is related to 6. So we can say that 6 is an upper bound. 6 is an upper bound. In the similarly, I can say that 2 is related to 12 and 3 is related to 12. So I can say that 12 is another upper bound. Another upper bound. Similarly, 2 is related to 24, 3 is related to 24. So we can say that 24 is also an upper bound. And similarly, 36 is also an upper bound. So for this set B, there are upper bounds. So those upper bounds are 6, 12, 24, 36. And suppose if I am going to consider this, naturally, so 2 is related to 2, right? And 6 is not related to 2. So this is not an upper bound. And 3 is also, 2 is not related to 3. It is also not upper bound. 2 is related to 6. 6 is related to 6. So for this also, the upper bound is 6 and 12, 24, 36. So for this also, we are going to get 6. And next for this, what are the upper bounds for this? Both. For both. So the upper bounds are 6, 12, 24, 36 are the upper bounds. And whereas if I am going to consider here, so 6 is not an upper bound because 12 is not related. So then 6 is related to 12, 12 is related to 12. So subsequently 12 is the upper bound. Next 6 is related to 24 and 6 is related to 34. So another upper bound is 24 and next another upper bound is 36. So for this subset, for this subset, the upper bounds are 6, then it is 24, sorry, it is not 6, it is not 6, it is only 12, 24 and 36 are the upper bounds, upper bounds. So like that, so whatever the subsets if you are going to consider from the given set, so it has an upper bound and of course it has lower bounds also. It has a lower bounds also. So here an element A belongs to A is called lower bound of the subset B of A related to X, A related to X, for all X belongs to A. For this subset, if I am considering for this subset, there is no lower bound because there is no element which is related to each and every element of this set. So here I am just proceeding like this. So here the set of elements which are related to all these subset, then we can say that it is the lower bound. So here there is no element in A which are related to the elements of B. So for this there is no lower bound. And here also there is no lower bound. And for this, what are the lower bounds? Lower bounds are, let us say, so 2 is not related to, see here, the lower bounds are 2 is related to 6, whereas 2 is related to 12. So I can say that 2 is one lower bound. And another one is 3 is related to 6 and 3 is related to 12. So 3 is another lower bound. And another lower bound is 6 is related to 6 and 6 is related to 12. So 6 is another lower bound. And next 12 is, so another element if I am going to consider, 12 is not related to 6. 12 is not related to 6, whereas 24 is also not related to 6. 36 is not also related to 6. So for this, the lower bounds are 2, 3, 6. And for this, what are the lower bounds? For this, what are the lower bounds? So here, if I am taking 2 is related to 2, okay, no problem, but 2 is not related to 3. 2 is not related to 3. So for this, there is no lower bound. No lower bound. There is no lower bound. And for this, B1. So 2 is related to 2. And next, 2 is related to 6. So one lower bound is 2. And another lower bound is 3 is related, 3 is not related. And of course, 6 is not related to 2. So the remaining is not there. So what are the lower bounds for B1 is? B1 lower bounds are only 2. B1 lower bounds are only 2. So here we are going to discuss some of the extremal elements. In that we know what are the minimal elements and what are the maximal elements and what are the greatest element and what are the least elements and what are the upper bounds and what are the lower bounds. So the upper bounds and the lower bounds you know already. So this is not a unique. Sometimes may exist one and sometimes it does not exist and sometimes exist more than one. Now let us consider another one. So what is the least upper bound? Least upper bound. So we know upper bounds, there are so many upper bounds and may exist. So in such a case, no problem if it is only one upper bound will be there, then automatically we can say that it is the least upper bound. If there are more than one upper bound, then what is the least upper bound? So for that, if it is satisfies these two conditions, one is their upper bounds. It should be, A should be an upper bound. Basic thing is, it should be upper bound. Before saying it is a least upper bound, and it should be an upper bound. Next, suppose there are some other upper bounds are there. Suppose there are some other upper bounds are there, then A is related to that upper bound. A is related to that upper bound. Then we can call it as A is a least upper bound. A is a least upper bound. See, A dash is another upper bound, A double dash is another upper bound, like that. There are many upper bounds will be there. In such a case, A is related to all the other upper bounds. Then only we can say that A is the least upper bound. And least upper bound we are going to represent. We are also going to call it as supremum. Supremum. And then supremum is also taken as least upper bound. Then similarly, the lower bounds will be there. So in that, what is the greatest lower bound? So an element A is said to be greatest lower bound. First of all, it should be a lower bound. And any other lower bounds will be there. All lower bounds are related to that. All lower bounds are related to that. So like this. Any other lower bounds will be there. All lower bounds are related to this. Then whereas the least upper bound is nothing but any other upper bound will be there. A dash, A double dash, A triple dash, like that. Then it should be related. Then it should be related like this. It should be related. Then we can call it as a least upper bound. And here the greatest lower bound means other lower bounds are related to that. Other lower bounds are related to that. So this is nothing but the greatest lower bound and the greatest lower bound. We are also calling it as infimum. We are also calling it as infimum. So these are the extremal elements in posets. So one is a minimal element, maximum element. Minimal and maximal elements may exist for all the partially ordered set. And the next, least and the greatest element may exist, may not exist. If it exists, it must be unique. And the next, another one is upper bounds. Upper bounds and lower bounds. Upper bounds and lower bounds may exist uniquely, may not exist uniquely, and sometimes may not exist also for some subsets. So how we are going to identify the upper bounds and how we are going to identify the lower bounds? Among all the upper bounds, how to find out the least upper bound and how to find out the greatest lower bound. See, A is said to be an least upper bound. First of all, it should be an upper bound. If any other upper bounds are there, and it is related to all the other upper bounds. It is related to all the other upper bounds. And an element A is said to be greatest lower bound. If any, first of all, it should be a lower bound, and any other lower bounds will be there, or other lower bounds are related to this. Okay. So now let us concentrate one example on this. So here, the set is given like this. The set is given like this. Whose Hasse diagram is represented here. And we have to consider the subsets, this one, find out what is the least upper bound, and next lower bounds, okay, of B1 and B2. So first of all, let us discuss about what are the least element and what are the greatest element of this diagram. So the least elements are does not exist. Least element does not exist for this. Whereas the minimal elements are exist. The minimal elements are 1, 2. Whereas there is no least element. Least element is not there. And the greatest element or maximal elements are only 1, 8. Because all the other elements are, because there is no other element in the set where 8 is related. All the other elements are related to 8, but 8 is not related to any other element. So I can say that it is maximum. And what about the greatest? What about the greatest element? So here, all the other elements which are related to 8 only. So here, maximal element will become the greatest element. Maximal element will become the greatest element. So this is the way that we are going to find out what is the maximal element, minimal element, least and greatest element. Now let us consider this is the B1 subset. And another B2 is 3, 4, 5. Another B2 is 3, 4, 5. So what are the upper bounds of B1, upper bounds of B2? And what are the lower bounds of B1 and what are the lower bounds of B2? That we have to discuss. Now, 1, 2 means only this. 1, 2 means only this. Now, what are the upper bounds of this? What are the upper bounds of this? So here, upper bound means that any element in the set given set A, any element in the given set A, so then it should be related to all the other elements of B1. All the other elements of B1. So B1 is what? This one. So first take an element 1 if I am going to consider. 1. So 1 is related to 1. But 1 is not related to 2. 1 is not related to 2. So it is the set I am going to write 1, 2, 3, 4, 5, 6, 7, 8. So here 1 is related to 1, no problem. But 1 is not related to. So it is not an upper bound. It is not an upper bound. Okay, upper bound means, sorry, I am just taking, this I am going to write like this. 1 is related to 1, whereas 1 is not related, 2 is not related to 1. So of course, we are going to consider in the previous one. See here, 1 is related to. Okay, so here, what are the upper bounds? So, 1 is not. And the next 2, if I am considering, 1 is not related to 2. So, 2 is also not an upper bound. Whereas 3, if I am considering, 1 is related to 3 and 2 is related to 3. 2 is related to 3. So, 3 is an upper bound. 3 is an upper bound. Similarly, 4. 4 is also 1 related 4 and 2 related 4. 4 is an other upper bound. 1 related 5, 1 related to 5 and 2 related 5. So like this, 1 related 5, 2 related 5. And next 6, 1 related 6 like this or any other way by using transitiveness. And next 2 is related to 6. Similarly 7 and 8. So for this, what are the upper bounds? So 1 is, I am just taking 1 is 3. 1 is 3 and 1 is 4, 5, 6, 7, 8 are the upper bounds. Okay, for this set 3, 4, 5, 3, 4, 5. What are the upper bounds? So 3, 4, 5. Which element is related? 4 is not related to 5. So 6, 4 is related to 6, 5 is related to 6, 6 is related to 6. So what are the upper bounds? 1 is 6 and another one is 7 and another one is what about this 3, 4, 5. So it is also 7 and another upper bound is 8. So these are the upper bounds. So this is upper bounds for B1 and these are the upper bounds for B2. And similarly the lower bounds. Okay, so afterwards I am just finding upper bounds are this. What is the least upper bound? What is the least upper bound of B1? See, so this is the set of upper bounds. Now 3, observe this. This is related to, when we say that A is said to be least upper bound, first of all it should be an upper bound and it is related to all other upper bounds. So 3, of course 3 is related to itself, 3 is related to 4 and 3 is related to 5 and 3 is related to 6, okay, and 3 is related to 7 by observing the diagram. 3 is related to 5, 3 is related to 4, 3 is related to 6, 3 is related to 7. Similarly, 3 is related to 8. 3 is related to 8. So we can say that the least upper bound of B1 is 3. Least upper bound of B1 is 3. And now let us consider for B2. What are the least upper bound? So the B2 is this. What are the least upper bound? 3, 4, 5. So 3, 4, 5. I am going to consider like this. 3, 4, 5. So in this, an element which is related to. So first of all, what are the upper bounds? These are the upper bounds. These are the upper bounds. So here, 6, 7, 8. 6 is said to be least upper bound. 6 should be related to itself, no problem. But how to verify 6 is related to 7 or not? 6 is not related to 7. 6 is not related to 7. Of course, 6 is related to 8, but 6 is not related to 7, so I am not considering that. And the next another one is 7. 7, if I am going to consider, 7 is not related. 7 is not related to that. 7 is not related to that. So 6, so 7 is not an upper bound. And the next another one is, let us say that the 12. So another upper bound is 12. So 7 and 8 is also upper bounds. 6 not related to 7. So now observe this. So what about 7 is not related to 6. And what about 8? If I am considering 8, 8 is not related to 6, whereas 8 is not related to 7. So for this, there is no upper bound. There is no upper bound. So when we say that least upper bound is, it should be an upper bound and it is related to remaining upper bounds. It is related to remaining upper bounds. So here 6 is not related to 7. So 6 is not least upper bound. 7 is not related to 8. 6. So it is not least upper bound. 8. Next element is 8. 8 is not related to 6. 8 is not related to 7. So 8 is not the least upper bound. 8 is not the least upper bound. So for this B2, there is no least upper bound. There is no least upper bound. And similarly, we have to find out what are the lower bounds. What are the lower bounds? So first, for B1, what are the lower bounds? An element which is related to the elements of B1 is said to be lower bound. I am taking 1. 1 is related to 1, but 1 is not related to 2. 2, if I am taking 2 is not related to 1, but 2 is related to 2. 3, if I am taking 3 is not related to anyone. Okay, 4, if I am taking 4 is not related to anyone. So here, lower bounds are nil. There is no lower bound. There is no lower bound for this. There is no lower bound. Whenever there is no lower bound, means there is no question of greatest lower bound. Greatest lower bound is also not there. And now consider for the next, for this, what are the lower bounds for this? What are the lower bounds is 1 is related to 1, 1 is related to 2, no, 1 is not related to 2. 1 is related to, the element 1 is related to 3, okay. Next another one is 1 is related to 3, and whereas 2 is also related to 3, 2 is also related to 3, and of course 1 is related to 3 means 1 is related to 4, 1 is also related to 5, 2 is related to 3 means 2 is related to 4, of course 2 is related to 5. Next 3, if I am taking 3 is itself related to 3, and 4 is related, of course 5 is related. See, 4, there is no 4 related to 3. 4 is not related to 3, but 3 is related, but 4 is not related. So 4 is not lower bound And of course, in the similar sense, 5 is also not lower bound, and 6 is also not lower bound, 7 is also not lower bound, 8 is also not lower bound. So for this, what are the lower bounds are? Lower bounds are only 1, 2, 3. 1, 2, 3 are the lower bounds. 1, 2, 3 are the lower bounds. Among this, which is the greatest lower bound? Which is the greatest lower bound? A lower bound is said to be greatest. First of all, it should be a lower bound. If any other lower bounds are there, they are related to A. So here, 1 is the lower bound, 1 is related to 3. 1 is related to 3. Similarly, there is another lower bound, 2 is related to 3. So we can say that greatest lower bound of this subset B2, greatest lower bound of B2 is 3. Greatest lower bound of B2 is 3. So I am just taking this is greatest lower bound of B2 is equals to 3. So in this way, we can calculate what are the lower bounds and what are the upper bounds, and what is the greatest lower bound and what is the least upper bound, like that. So here there is no element x such that, so there is no lower bounds for this. There is first B1 and there is no greatest lower bound. And similarly for that, there are upper bounds, 6, 7, 8 are the upper bounds, but there is no least upper bound because upper bounds are not related to any other upper bounds. And of course, the same remaining one is lower bounds are exist for B2, and in that the greatest lower bound is 3. Now let us consider another one. This is the Hasse diagram is given. Okay, and another one is CDE. CDE. This is one subset. So we have to find out what are the upper and lower, of course, least and greatest elements. So what are the upper maximum value? Find all maximal and minimal values. Sorry, this is not a maximal and minimal elements. Minimal and least upper bound, greatest element bound of this. So maximal elements are only GH. So top. That means it is not related to any other element of the given set A. A is consisting A, B, C, D. A is what here? A is just to have to consider A, B, C, D and so on. GH. This is the set. And for this set, maximal elements are GH. And minimal elements are A, B. And next, least element is, there is no least element. There is no least element, or we can say that nil. And the greatest element is, nil. So these are the ways: the maximal element, minimal element, least and greatest element. Next, we have to find out what are the bounds of the subset CDE. See what are the CDE upper bounds are. See an element where these are related to, say, F if I am taking, C is related, D is related, E is related. So I can say that F is one upper bound. Another upper bound is G. All the elements of the subset which are related to the elements of the given set, then we can say that those elements are upper bounds. So the upper bounds are F, G, H. These are the upper bounds. These are the upper bounds. Whereas the lower bounds of this, is A, B, C. That means the elements of this set are related to this, are related to the elements of B. So A, B, C are the lower bounds. So in this, what is the least upper bound? Least upper bound means, see here, F is related to G and F is related to H. So I can say that F is the least upper bound. Whereas among these lower bounds, what is the greatest lower bound is? See here, A is related to C and B is related to C. So I can say that C is the greatest lower bound. C is the greatest lower bound. So in this way, we can find out what are the least upper bound and the greatest lower bounds. Greatest lower bounds of a subset. Suppose if I am going to consider another subset, if I am taking B1 as, let us say, FGH. If I am taking another subset, B1 as FGH, in such a case, there is no upper bounds. Upper bounds are not there. Because all these three elements are related to an element of A. Such possibility is not there. So B1 upper bounds are not there. So there is no least upper bound. Whereas the lower bounds of B1 are, see what are the lower bounds are? One is A, B, C, next D, next E, F. These are the lower bounds. Among these lower bounds, what is the greatest lower bound is? The greatest lower bound is F. So in this way, we can calculate what are the least upper bound and what are the greatest lower bounds. Next, another one is, see, this is given. Consider a poset is given whose Hasse diagram is there. Find out what are the least upper bound and the greatest lower bound, and of course minimal, maximal, least and the greatest elements. So here just what are the maximal elements are? Maximal elements are F, G, and the greatest element is, there is no greatest. Greatest element is, there is no greatest. Maximal elements are there, F and G. And here, because I cannot say that F is not related to Z, and whereas the other elements are related to F, but F is not related to G. So I cannot say that it is the greatest. And what about the least elements are? Least element is also does not exist. And minimal elements are A, B. Minimal. These things are for the entire diagram or for the entire poset. Okay, and whereas the upper bounds and lower bounds for the subsets. C, D, E. Okay, I am just considering this. C, D, E. What are the upper bounds? Upper bounds are E, F, G. E, F, G are upper bounds. So in these upper bounds, E is related to E, of course, E is related to F and E is related to G. So we can say that E is the least upper bound. And what are the lower bounds? So C, E and D. C, D, E. What are the lower bounds are? So of course C is itself, but there is no relation here. So the lower bounds are only A. Lower bound is only A. Lower bound is only lower bound of lower bound. Where is that? Lower bound is A. Lower bound is A. So whenever any one single element will be there, then automatically the greatest lower bound is the element itself. Now let us consider the other element. Find out maximal and minimal of the diagram. So it is given, the elements A is given and the relation is a divisibility relation. The divisibility relation will be there. Now we have to find out. So first one, take the incomparable elements. So here there is no relation between these two. So I am going to write these two are at the bottom. Next, another one is 9, 15, 24 will be there. 9, 15, 24. So I am just 3 divides 9, 3 divides 15. And so sorry, I am not taking like this. And 3 divides 24. 3 divides 15. Of course, 5 also divides 15. 5 also divides 15. And see here, these 3 are, there is no relation. 3, 9 does not divide 15. 15 does not divide 24. So I am going to write in the second level. 9, 24, 15. Whereas any divisibility will be there. I am just taking a line segment, connecting those 2 points. Otherwise, not required. And all elements are 3 divides 45, 5 divides 45, 9 divides 45, like that. So the topmost one element is 45. So this is the Hasse diagram for the set consisting 3, 5, 9, 15, 24, 45. And of course, there is a divisibility relation. Now for this, what are the maximal elements? Maximal elements are 45. And what is the greatest element? Greatest element is 45. Because here all the other elements of the sets are related to 45. So maximum element will be equal to the greatest element. And similarly, minimal element. So 3, 5. And the least element, there is no least element. So in this way, there is no least element because 3, 5 there is no relation. 3, 5 there is no relation. Suppose if I am going to take here, it will be 5. Let us say if I am connecting like this, I can say that the least element is 3. Otherwise, I won't say the least element is not exist. So the least element does not exist here. So the minimal elements are exist and the maximal element also exists. So first one is why I am writing these at the bottom. So because there is no relation between the elements 3 and 5. So there is no comparison. That means uncomparable elements means that there is no relationship between those two elements. Either A related B or B related A. In such a case, we said that those two elements are not comparable. So in such a case, where are the elements are not comparable? I am just taking at the lower end. And the second level, non-comparable elements I am going to write in the next level. And of course, at the top, I am going to write the elements which is related to itself. So the construction way, here there are 3 levels will be there. So here this is the first level and this is the second one and this is the third one. So in that way we are going to draw the Hasse diagram for this, and afterwards we are going to find out what are the maximal and minimal, least and the greatest values that we are going to find out this. That's all today's session, and tomorrow next session, we are going to solve some more problems on this extremal elements, and after that we will go to the next topic, lattice theory. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.